Welcome to our video lecture series of flexible AC transmission systems device. Today is our 7th lecture. We shall discuss more in detail about the multi-level converter or inverter. It is used for actually we shall use the abbreviations of multi-level inverter as MLI, and classification of the multi-level inverter can be actually cascade. Then first we will discuss about the classification of the multi-level inverter, then cascade HB multi-level inverter will be discussed in detail. This is one form of the multi-level inverter, and thereafter different kind of PWM technique required to operate this multi-level converter or inverter properly. That is carrier based PWM for HB's cascade multi-level inverter. There are phase shifted PWM, we have a level shifted PWM, we can have hybrid PWM and third harmonic injections and hybrid PWM of asymmetric condition, and we will show some simulation results and we will compare with a different type of PWM technique in our content. So, why multi-level inverter? Multi-level inverter is actually a composed of the series of the or array of the power electronic semiconductor with a capacitive voltage sources. It generates voltage in multiple steps because we generally required to generate sine wave, but in case of the PWM we generally actually give plus minus VDC. So, there is a huge instantaneous voltage error between the actual voltage required by this inverter and the actually the PWM generated voltage. And here in case of the multi-level inverter, since it applies voltage in steps, so more will be the steps, more actually to be closer to the sinusoidal. So, thus voltage waveform with variable and the controllable frequency, phase and amplitude. Again moreover it generates voltage and current waveform with the improved quality, because the instantaneous voltage that required to be injected by the inverter and actual voltage injected by the inductor was the inverter is less in error, because you can apply voltage in steps. Since cost of the power electronics devices go high with the rating, so we require to increase the power handling capability of the device by connect them in series. For this reason it is used for the high power and the high quality power management applications, and it is one of the basic need for our fax devices. And some applications are, of course, all the application is fax devices, STATCOM, SBC we will see later. These are basically now uses multi-level inverter. Apart from that, we can have hybrid electric vehicle, wind energy conversion system, photovoltaic energy conversion system, UPS and reactive power compensations, STATCOM, SBCs, etc. Now, what are the features or what are the desirable features of the multi-level inverter? One of the essential drawback is that you require more number of switches. So, what should be the advantage of having a multi-level inverter? The higher voltage operating capability, since the devices are connected in series, so voltage blocking capabilities gets doubled. Most of these fax devices are connected in a distribution system of 6.6 kV. For this reason we have to mandatorily use these devices. Thereafter lower common mode voltage and reduce the voltage derivative DVDT. Since it can works on a voltage on a steps, so we can see that instead of the it can apply VDC, it can apply VDC by 2 like this. So, we can find out the rate of change of VDC with time is actually less compared to the 2 level inverter. Voltage just with reduced harmonic content, as I told, because let us say we require to generate, this is the voltage, and if it is a PWM you generate this voltage or this voltage to generate. So, when you are applying this voltage you have huge instantaneous error, and that is one of the source of the harmonics. But in this case what happened, since you can apply something like this, instantaneous error is half. So, if you go to the for the 3 level inverter, if you go to the minimum level, so this instantaneous error get diminishes. And what else? So, since due to that this harmonic content will be reduced. Since harmonic content will be reduced, and thus you require smaller filter, smaller size filter to eliminate, and it increases efficiency. We can find it out because there is a, if it is a hard switching, so hard switching losses of the 2 level inverter quite high compared to the multi level inverter, even though number of switches are more. And we can actually put redundancy in the circuit, and thus we can introduce the fault tolerance capability with this multi level inverter. Now, this is the example. We try to realize the multi level inverter with simply a mechanical switch. In this case it is a single pole double throw switch. In this case it is single pole triple throw switch. In this case it is single pole multiple throw switch. So, this is the realizations of the 2 level inverter. So, when it is connect like this, then it is connected to the upper DC bus voltage. So, you will get a voltage VDC, and once you connect a lower DC bus voltage, so you get minus VDC. So, voltage will swipe from plus VDC to minus VDC. Thus, you can see here the how huge instantaneous voltage error, and this is actually a 3 level inverter, and this is a multi level inverter, where actually voltage is switching over 0 to plus VDC. It can be connected VDC, it can be connected to 0, that is end point of the midpoint of the DC link capacitor voltage, and it can be compared to the lower end of the switches. Thus, you can directly you can see that stress here is halved, and instantaneous voltage error also been halved. You can have the multi level inverter, and you can see that actually this error is minimized greatly. Now, we shall come detail the application aspect of this multi level inverter. Multi level inverter can be broadly classified into single source. Generally, you will find that this is the most used topology, that is neutral point clamp, that is or diode clamp topology, and you will also have a capacitor, and it is the simplest topology, and it is finds much more application. And next topology is a flying capacitor. Here actually voltage applied to the different charging and discharging of the capacitor, but to operate it properly you require to charge and discharge the capacitor in a controlled manner to get the desired voltage. Thus, there is a complex construction involved, and you can have a cascade multi level inverter. So, you have a modular kind of setup, you can increase the number of module by simply using the number of the modular switches, but disadvantage is that in case of the cascade multi level inverter you require to have a separate DC source. Nowadays this application finds this kind of topology finds a lot of application in solar inverter, because you have a solar panel that can be treated at isolated DC sources, and so thus you can generate a different kind of voltages. So, you can have an equal DC source voltage, or you may actually try to generate this, so that you can actually replica of this your sine wave. So, that can be used for the unequal DC source. Now, let us understand the application of the simple neutral clamp or the diode clamp inverter. Now, let us understand 1, 2 and 3, these are the points. Now, when it is connected to the point 1, let us say of the pole A, then current can be bidirectional. Let us see that what kind of switch is required here. Current can be bidirectional, so you require to have a switch that require actually the bidirectional bidirectional current conducting capability, and also within the point 1 and 2 you require to 1 and 2 the blocking voltage VB required to be VDC, or here in this case it is VDC by 2. Same way with the blocking voltage between 1 and 3 required to be VDC. So, this is all other cases. So, how you realize it, and when you put this is the position 1, same way what about position 2? When you place it this switch here, again actually it should have a bidirectional current carrying capability between the point 2 and A. So, we require a switch that is that can actually allow to current to flow in bidirection. Again it can block the voltage of VDC by 2 in between the point 2 to 1. So, there is a minus sign involved, and this is it required to block the voltage of minus VDC, and same way VDC by 2 you will find in between actually 2 to 3. This is the condition. Same way when it is put into the position 3, same way current required to be bidirectional, and it required to block the voltage between 3 and 2, that is VDC by 2, and 3 to 1, that is VDC by VDC. So, how you will realize it? With the switches. Now, this is the switch. Before that, we can take a whiteboard to explain it. So, what it does, it require. So, this is the point, let us say A, and this is your the DC bus voltage, and you have a diode clamp circuit. Now, you realize that when it is connected with it, it required to block the voltage. So, when you want to connect this voltage, it required to block the voltage of VDC. So, we can, and it current required to be bidirectional. So, what we can think of, we can connect a switch here with anti-parallel diode, that another switch with the anti-parallel diode and this point. Thereafter, it has to block the voltage of VDC, and this point is a midpoint of the capacitor. It has to again block the voltage VDC by 2 in this configuration. Now, in next configuration, similarly, when you come to the, this is actually position 1, same way when you come to the position 2, then what happen? This switch gets shorted. So, and it has to be bidirectional. For this reason, we require to have a switch that is in bidirectional in nature. So, we can realize a 4th quadrant operation of the switches. So, here so you require to have a anti-parallel diode. So, and above it you have 2 switches. And similarly, you have when it is connected to the position 3, it will be the same position for 1. So, you have these circuits, but you see that to realize for one leg you require the 6 switches. So, can we have some kind of redundancy here, and can we not minimize it? So, here you can see that, let us name it S1, S2, S3, S4 and name it SW1 and SW2. And what happened here, when we want that this pole A to be connected to the upper end of the DC bus voltage, then of course, what are then actually we write that actually S1, S2 and S3, S4 if you write. So, S1, S2 should be 1, S1, S2 should be 1 and S3, S4 should be 0. So, you will connect it into the lower switch, the positive DC bus voltage. Same way, if you wish to connect, there is a redundancy. Where you can connect, because you have a capacitor midpoint. So, this point will be connected here. You can find that if you connect a diode simply through this point, and it can work anyway. And so, if this switch is on, and ultimately this switch can work. So, similarly, if you wish 1 1 0, that is when you connect, then this 2 is on, then what happened, we can have some kind of redundancy here. This generated voltage can generate 0 in this configuration. In this case, you get VDC, and when it is 0 0 1 1, you get VDC minus VDC. And how you get 0? There is a many combination. Now, see that if I can switch over to the practical circuit, and here we have put 2 switches here. Instead of that, we can connect a diode, and you can use the switch S2, and thus what will happen, these 2 switch, and similarly in a lower half this diode will conduct. So, instead of these switches, we can replace it by a diode. So, this is the optimal circuit you will get, and ultimately this is the diode clamp realizations, and where when you give pulses, accordingly switching will takes place. So, what is the switching configuration? Only 2 switch of the upper leg receive the signals to generate plus VDC, only 2 switch for the lower leg will get a signal for generating minus VDC. So, for this reason, switch pairs SA1 and SA2 receives the positive signals, and SA2 and SA2 receives the getting signal, and to avoid the DC-link of the short circuit condition. Similarly, here this pair of switch will receive the inverted signals, and this pair of switch will get a positive signal. One of the 4 binary combination is sufficient to represent those switches. So, we have shown in the black previously that the combination of the switches S1 and S2, S3, S4 will be combined in such a way, and we will find some kind of redundancy of here. When S1, S2 is on, that is connected with the positive DC bus voltage, then what essentially you get here, you get a voltage VDC. Similarly, when this S1 bar and S2 bar is closed, you get minus DC bus voltage, and when S2 and S1 bar is closed, you essentially get a 0. So, thus you can actually one aspect you can see, let us write it again and see that what happened. So, the switches are S1, S2, S3, S4. Now, and we have already put the switches, you have seen it is SA1 bar and SA2 bar. When you require to generate VDC, that means 2 upper switches be closed, let us make it upper switch closed by 1 and other will be 0. When you want 0, so it will be the condition. When you want minus VDC, you will have this. So, from there you can see this the two table that S1 and S3 are complementary to each other and S2 and S4 are complementary to each other. So, for this reason S1 can be written as S1 bar, S4 can be written as S2 bar. So, thus this nomenclature is used there. So, see that it is S1 bar, S1 and S1 bar. So, to avoid short, we require to ensure that switch pair SA and S1 receive a positive signals and SA S1 and S2 and S2 bar receives basically the inverted signal, because it is a complementary logic and that will ensure a never shorting condition of the DC link voltage. One of the 4 binary combinations, that is let us make S1 and S2, is not used since it does not provide the current path to the load. All the switches of the 3 level inverter need to be block only half of the DC bus voltage, and since you know that when you can choose a single switch of rating of VDC, but instead of that, because here you can choose a half of the rating. Generally cost of the switches increases very high with the rating and thus it helps to reduce the switch rating. And another aspect, the uniformity. All the switches having a same blocking capability of VDC by 2, that gives some kind of redundancy in our designing. Now, this is the mode of conduction. When upper to switch on, it has been bolded. So, in S1 and S2, so you get a positive DC bus voltage in between the point N and A. So, you get this voltage. Similarly, when these two S2 and S3 are on, later we can write that S2 as S2 bar. So, what will happen here? You can find actually the 0 voltage here. Similarly, when lower switch is on S3 and S4, you get minus VDC across VAN. This is a simple operation and you can extrapolate to the any level, and one of the advantage of it is the simplicity of the operation. Now, what are the advantage of diode clamped or the neutral point clamp MLI? Compared to the 2 level inverter, the output voltage waveform of the 3 level inverter has reduced THD. It is because instantaneous error of the applied voltage and the generated voltage by the inverter is less, and also less DBDT. Same case, because rate of change of voltage for multi level inverter are in steps, not plus minus VDC. As the level increases, number of the clamping diode needs to be shared, the voltage increase dramatically. Increasing difficulty to control the DC link voltage unbalance. So, let us understand what happened there. So, we have shown the case here. So, this is basically the multi-level inverter. Since this capacitor voltage is not actively controlled, so current coming and discharging, current coming into the system and going out will basically give the status of the amount of the charge, and that will be reflected as the voltage available at the DC link. So, in this case, if all of a sudden there is a mismatch of the current pattern, then one of the declining voltage may discharge faster and thus it will generate unequal voltage distribution. This is one of the disadvantage of the diode clamp inverter, and this problem, for this reason we require to solve this problem, and for this reason we require to actively charge and discharge the capacitor, that we usually do in case of the capacitor clamp multi-level inverter. So, for this reason we find that very high level NPC are not recommended and it is restricted only to the 3 level 4 level inverter. And moreover, additional clamping diode in a neutral point voltage deviation is complicated design pattern it gives for the analysis, and this is also one of the disadvantage of the diode clamp multi-level inverter. Now, we shall start briefly the capacitor clamp multi-level inverter. We will continue to the next class. Basically, we can also realize capacitor clamp 3 level multi-level inverter with the help of the SPDT or SPST or mechanical switches. So, this is the point A and this required to be controlled, and if you wish, and ultimately if this switch is closed, then it will be connected to a DC bus voltage. Again, similarly, if this switch is closed and if this position is here, it will be connected to the negative of the DC bus voltage, and here you can change the polarity. While you are in this position, and if you open this switch and close this switch, then you apply minus VDC from, and so will be subtract minus VDC by 2, we assume that this voltage is VDC by 2 and this voltage is VDC by 2 and this voltage is also VDC by 2. Here you will actively monitor the voltage of it where it will be applied here. If you close here, it will be essentially minus VDC by 2, and if you put this position, then it is minus VDC by 2. If you close this switch and if you keep this position, then essentially you get minus VDC by 2. Same way, if you close this switch and if you put it here, you get plus VDC by 2. So, in that way you can generate a multiple state of the voltages, and here this disadvantage is not there because you are controlling the voltage actively. But one of the disadvantages of diode clamp voltage is that complexity of the complex circuit that I am coming later. So, how you realize with the switches? Essentially, this can be realized by these switches, because current required to be bidirectional. This configuration of the IGBT gives you the bidirectional current and unidirectional voltage blocking capability between these 2 points. Similarly, it gives a bidirectional current and unidirectional voltage blocking capability, and you can close any of the switch here and here, accordingly you generate the voltage VDC and minus VDC by 2, and this is the simplest way of realizations of 3 level diode clamp multi-level inverter. Now, this is the actual circuits of the diode clamp realization, and we shall continue with this circuits in our next class, and we shall discuss it, what is advantage and disadvantage of this flying capacitor multi-level inverter. Why it is called flying, that also will be explained now. Thank you.